everyone, this is a Math OED2 video 3.4, Introduction to Polynomials. In my last video, I identified like terms in polynomials, and we said that a like term means that it has to have the same variable raised to the same power or exponent. So for example, x plus y are not like terms, x plus x squared are not like terms, and 2 plus x are not like terms. So let's try to look at some things which are like terms. So some examples of like terms would be like 2x and 3x. Okay, I can add those together and get 5x. Other examples would be like negative 5x and x. That would give me negative 4x. I could have x squared and 7x squared. Those are like terms. Subtracting them would give me negative 6x squared. And of course, numbers, right? If I had 72 minus 2, that would give me 70, just like you learned in arithmetic. So let's use this concept of like terms to actually work through an expression and simplify it. So the way I like to do this is I love colors, and I love to go through and use colors to identify my like terms. So I'm looking at this. This is a 4x cubed. Can you find any other expressions in here that have another variable x that's raised to the third power? Okay, I see this term right here. So these are going to be like terms. All right, let's keep moving on. Now I see a negative 2x. Do you see any other term where there's just x? I don't see anything else. So there's probably nothing else that can be combined with 2x. All right, let's keep going. What about plus 8? Here's plus 8. Are there any other just plain numbers? Well, there's minus 11. Okay, and then for our last term, we can circle it, is negative 9x squared. And hopefully you can see that there's nothing that can be combined with negative 9x squared. Okay, so these two expressions that are in parentheses are being added together. So the first thing we could do is that we can just drop the parentheses, because they're really not doing anything for us other than visually grouping two sets of terms. They're not serving any other purpose. So let's go through this and combine our like terms. The way I like to do it is I like to rewrite my expression so that my like terms are adjacent. So I have a 4x cubed and I have a 3x cubed. So I'm going to rewrite this so that they are adjacent to each other. All right, let's pick another color. Let's pick blue here. No, let's pick dark blue. Okay, so our next term that I'm going to write is minus 9x squared. So as you continue working through and using polynomials, you'll discover that we write them in descending powers of x, which means we start with the highest exponent, in this case 3, and then we go down to 2 and 1, and then our constants. That's just generally how we write polynomials. Okay, so then we have minus 2x. Okay, because remember there's no other x squared terms that I can see anyways in this equation. And then we have a plus 8, and we have a minus 11. Okay, so if you can see colors, then hopefully you can see that these two terms can be combined. So another way, this is kind of silly, but I like to think about it this way. I like to talk about each term being a different fruit. So let's just say that x cubed is bananas, and maybe x squared is grapes. Okay, and again, I'm making this totally up. And maybe x is peaches. Because as students do this, they tend to want to combine or in somehow change the exponents. Okay, so instead of reading this as 4x cubed plus 3x cubed, read it to yourself as 4 bananas and 3 bananas, right? 4 bananas plus 3 bananas is 7 bananas. Okay, you still have bananas. They didn't somehow magically transmogrify into some other fruit. They're still bananas. They haven't changed. You're just counting how many things that you have. In our case, the things aren't bananas. They're x cubed, but they're still x cubes. They didn't magically transform into some other thing. Okay? So let's keep going. So I'm going to bring down the minus x squared. Again, it doesn't have anything to get combined. Then bring down the minus 2x. Okay, and then here, right, plus 8 minus 11 gives us a negative 3. So that's our final answer. Let's do one more problem while we're working on this. Okay, so again, we can use colors, and you can either highlight, circle, underline, however you want to do. Okay, now I want you to notice in this problem, there is a plus sign here, but look, there is a minus sign here. And that is really tricky because what that means is that this negative sign, which is really a -1, has to be distributed to all of the terms in there. So before I even try to go through this problem and identify the like terms, I'm going to rewrite it without the parentheses. That's going to be my first step. Sorry about that. Let me put down my wrist guard. I think that's supposed to be a wrist guard. Okay, so we have 2x squared, that is not helping me, minus 4x plus 3 plus 5x squared minus 6x plus 1. Okay, so this is where it gets tricky. So that -1 acts on the x squared, so it's -1x squared or -x squared. Okay, then -1 times -9. Those negatives cancel out and become positive. Okay, and then here -1 times +8 gives you a -8. Okay, now that I've eliminated all my parentheses, and again, remember here I had to also distribute that -1. I couldn't just drop the parentheses and move on. I had to do some work first. Now that we've done that, we can go through and identify our like terms. So I see a 2x squared here. Let's look and see if we see any x squared terms. Do you see any? So I see 5x squared. That looks like a like term. And I have a -x squared or a -1x squared. So what I'm going to do down here is I am going to arrange them so that they're adjacent to each other. And generally speaking, this is a pretty good practice to get in the habit of doing. All right, so after x squared comes x. Remember, we worked in descending powers of x. So I have -4x. I'll bring that down. Looks like we have -6x. We'll bring that down. And we have a plus 9x. We'll bring that down. All right, let's use this color blue. Okay, so now we have a plus 3. We'll bring that down. Looks like a plus 1. Bring that down. And a -8. Okay, so let's keep using these fun colors to combine our terms. So we have 2x squared and 5x squared gives us 7x squared. 7x squared minus 1x squared gives us 6x squared. Okay. How about over here? So we have -4 and -6. That gives us a -10. Minus 10x plus 9x gives us -x. Okay. And then over here, 3 plus 1 is 4. 4 minus 8 is -4. Now my numbers are all kind of spread out here, so I'm just going to rewrite it so it looks like a polynomial and not just random numbers and letters floating out in outer space. So if all of the arithmetic is right, that should be the correct answer.